Okay, we're live. Awesome. Thanks a lot, Bam, for all your help in setting it up. So sorry, everyone, if you're a bit late. There was some issues setting everything up this time. Okay, great. So welcome, everyone. Just wait a bit for more people to come in. Great. Feel free to drop a message in the chat. Tell me if everything is okay. So either on YouTube, Rumble, or in the Telegram group chat. Maybe not on Rumble because I can't really follow Rumble messages during the live. Hi Pirma, hi Geoffrey. I don't know how you pronounce. I'm going to say Geoffroy, but feel free to correct me. Welcome everyone. I'm just going to wait a few more seconds and we're going to start. Hey George, welcome. Great. So welcome everyone. I see some new names. That's great. All right. Hopefully you should be able to see the slides. Great. So quickly, while we wait for other people to join, because I see some new names, maybe I can do a quick overview of what Plan B Labs Lightning is and what the goal is. It will be quick, I promise, because for some of you, it will be like the sixth time that you hear this. Yeah, basically the goal is to have a community. So with a Telegram group and with bi-weekly live, like the one we are doing right now. And during this bi-weekly live, we will do all kinds of things, discuss recent news, dig deeper into some specific aspects of how Lightning works. And the idea is also to have some practical exercises, some practical experiences with either exercises like we are doing to do today, or with bigger projects, for example, which is something that we would like to set up for quite quickly. Actually, we will see how we can go with it. And so that's just who I am quickly. I contributed to Plan B Network educational content with a course devoted to Lightning, and I'm currently working in a Lightning company as a developer. And so the live sessions, something that I really want to emphasize today is that the live sessions are ideally, it shouldn't be me talking alone. It would be great if we could have some people join me here on stage. So we'll see what are the best tools for that. We'll try something today. We'll have some feedback about that, and we'll see how we do it next time. But I really want to encourage everyone to participate. And if you don't want to come on stage, you can participate in the chat and so on and so on. But we'll see how it goes. Here it's just a quick link to the LNP21 course on planb.network. It's not mandatory to know the content of this course in order to follow the labs, but it's a bonus. But once again, everyone is welcome. And here is, if you follow this QR code, you'll find a link, an invitation link to the Telegram group, where we have a few different channels to discuss Lightning news, to discuss exercises and stuff like that between sessions. So that's really where we coordinate between sessions. So please join the Telegram group if you're interested in the lab. Of course, few rules. Be nice, everyone. Don't insult each other. Don't promote shitcoins, stuff like that. And today, what are we going to do? We're going to review some exercises that I published on the Telegram group and on social media as well. and do a deep dive on what I call pre-image piracy or pre-image stealing. So that's what the exercise is about, and we'll have some more theoretical introduction to the context of what pre-image stealing is, and then we'll deep dive into the exercises. And if we have time, we'll also take a look at the news. But the last 2 weeks were quite quiet in terms of news. So yeah, I kept it for the end of the session. So this way we can focus on the exercise, on pre-image stealing. And if we have time left at the end, we can take a look at some of the news from the last 2 weeks. Great. Are there any questions before we start? So once again, the best places to post your questions or comments are in the YouTube chat or in Telegram. In the Telegram group, there is a live chat channel, a live chat topic, where you can post messages during the live chat. I try to keep an eye on this chat as well. Awesome. Great. And so now maybe we can start with the exercises. So here is a more detailed summary of what we are going to do today. So the news roundup isn't. I forgot to add stuff, but it will not be only the Misty Breeze news. It will be also some more generic wallet-related news. But the main part today is a topic on pre-image piracy, pre-image stealing. We'll start by reviewing what Polar is. So we introduced it in the last episode, so 2 weeks ago. But yeah, it would be great to see once again what it is, how it works, and to walk through a first example. And then we'll get some theory around what pre-image stealing is. And then we'll go back to Polar in order to review the exercise that I proposed to you last week. So hopefully some of you had some time to take a look at the exercise on your own at home. And so please, if you do, I would love to have you come with me on stage. I can share you a link and you can join me here on YouTube. If you don't want to join because, for example, you don't want to be in the replay or stuff like that, because maybe that's one of the reasons, tell me, because this way maybe we can, if we see that a lot of people would like to join but they don't because of the replay, maybe we can see to have the live sessions split in two. One part which will be available for replays, and another part which will be on a web conferencing platform, and where we won't share a replay afterwards, because one of the goals of the lab is really to have some interaction between students. So if that's the main obstacle to this kind of interactions, we can see to have part of the live being a bit more private without any replays. So yeah, so just tell me if that's something that maybe is right now one of the reasons for maybe you not wanting to join to join me on stage. All right, awesome. So without okay, I'm going to stop sharing this for a moment, and I'm going to share my web browser instead. Let's go. Share screen. All right, awesome. So you should be able to see GitHub now. Yeah, some slight delay. Yeah, it's working. Awesome. So this repository is on GitHub. So it's github.com/Fanis Mikalakis, that's my name, /polar exercises. And so that's where I will be posting the exercises. Maybe we will move it to the Plan B repository at some point. But for now, it's more practical to have it here. And so in this repository, which I hope some of you already visited, you have the instructions to install the tools that we will be using for the exercises. So one of the tools is Polar. So if I follow the link, we end up on the website. You can easily download Polar on your machine. So it's available for Mac, Linux, and Windows. So you should be whatever you are running, you should be able to use Polar. If not, please tell me. And another thing that you need in order to make Polar work is Docker. So Docker is a way to run what we call containers. And so basically, it's a way to run, let's say, small programs on your machine. And we will use Docker in order to run a fake Lightning Network right on your machine. So instead of having to use the real Lightning Network, we will use a fake Lightning Network. And so each one of you will have its own fake Lightning Network on its own machine. And so to make it work, you need to install, so on Mac and Windows, you need to install Docker Desktop. And on Linux, you will need to install Docker Server and Docker Compose, so both tools. So you can follow the link and follow the install instructions. You can also use a tool called OpStack. So that's what I say here. So OpStack is an alternative to Docker Desktop. It's basically, it's still Docker behind the scenes, but it's an alternative to Docker Desktop. So let's see what is supported. So Apple is supported, but maybe other... no, only Mac. So if you're on Mac OS, you can use OpStack. But if you're on Windows or Linux, you can use Docker Desktop, or if you're on Linux, Docker Server and Docker Compose. Anyway, once you have all this set up, you can then launch Polar. We'll get to that in a moment. And we'll see, how Polar works. So I'm going to share another screen. Here you go. Yep. Okay. All right. So I'm just checking if there are questions. Nope. So here I'm sharing the Polar application. We already touched on this 2 weeks ago. So I'm going to quickly show you how you can create a new network. So I already have here OpStack, but you can do with Docker Desktop as well. So I already have it running. So you need to have both Polar and Docker Desktop or OpStack running. And then you can either use a network that you already created, but if it's the first time, you shouldn't have any. And you can create a new network. So I'm going to call it demo network, for example. And then you can write a description if you want, and then you can configure how many nodes you want to have in your network. And so you have different Lightning implementations that are supported, namely LND, Core Lightning, and Eclair. And of course, each Lightning node needs to be connected to a Bitcoin Core backend. because a Lightning node needs to have access to on-chain data in order to detect, to know if a channel is open, for example, or if it is closed, and things like that. But you can connect multiple Lightning nodes to the same Bitcoin Core backend. So that's why, for example, in our demo, we will have, for example, three LND nodes and only one Bitcoin Core node. And if I hit the Create Network button, you can see that here automatically my three LND nodes are all connected to the same backend. So they will all use the same Bitcoin node as their data source for on-chain data. Of course, once we have created our network, you can still add additional nodes. And what you can see here is that you can pick across different implementations, but you can also pick each version independently. So you have access to several node versions for each implementation. If you select, the first time you select a specific node implementation and a specific version, it will need to download the Docker image for this specific version. So it will take just a little more time to set up because there is a download time. But once you've downloaded it, once it will be saved locally and you won't have to download it again. But for example, I can add a core Lightning node, version 24.1. So it's saying here that starting this network will take a bit longer than normal because it uses Docker images that have not been downloaded yet. So that's what I just explained to you. And I can decide that I want my core Lightning node to be connected to a different backend. So I can just change backend here. So I select the node, I hit change backend, and I can tell Polar that I want the Dave node, which is the core Lightning node, to be connected to backend 2 instead. And it will reflect here instantly. And so now I can, for example, if I'm satisfied with my network, I can hit start. So it will take some time here because it needs to download the Core Lightning image for version 24.11 of Core Lightning. But once the download is done, it should start quite quickly. Yeah, here we go. And now that I have my network, you will see that I have 4 Lightning nodes connected to 2 different Bitcoin nodes, but I don't have any channels between my nodes. And so I can start doing this. So there are little dots on the sides of your Lightning nodes, and you establish Lightning channels between them simply by clicking and dragging a connection between 2 nodes. So it's very intuitive. There you can specify if you want to change actually the 2 nodes, you can, and you can specify the capacity. You can automatically deposit enough funds to Alice's node in order to fund the channel, because initially there is 0 sats on all nodes. So this way you don't have to take additional time, additional steps to deposit enough funds. It will be done automatically. And you can decide to make the channel private or unannounced if you prefer. And so if I hit open channel, it will create the channel opening transaction, and it will mine some blocks automatically on the fake Bitcoin network that is running on my machine. And we should see a channel appear, which we don't right now. Maybe if I hit quick mine. Nope. Okay. Weird little bug. First time it happens to me. I can open a channel between Bob and Dave, for example. Let's open a channel. All right. And I can also open a channel, for example, between Bob and Carol. So as you can see, it's with the user interface, it's quite easy to do. So I just don't know why. Maybe I need to refresh. No. Because the channels should appear. Let me just try to quick and come back. All right. So it's a demo effect. Maybe if I stop the network and start it again. Because there should be a link appearing between Alice and Bob here, but we don't see it in the graphical interface here. I don't know why. All right. Because I think it has the channels. Yeah, it has one active channel, but it's just not represented whereas it should be. And this node, Bob, has 3 Lightning channels, as expected, because we opened one from Alice to Bob, and then we opened one from Bob to Carol, and one from Bob to Dave. So that's what we expect. Here we expect a 1, and here we expect a 1 channel. So I don't know why the channels... here they go. Okay, a little delay. But now you can see what I was talking about. So you can see each channel. If you click not on the node, but on the channel, you can see the channel details. So with the capacity, with the source balance, so here the source being Alice, and the destination balance, with the destination being Bob. And you can see all kinds of things. You can close the channel and stuff like that. And we can also, if we right-click on a node, we have access to some actions that we can do. And for example, we can create an invoice from Carol's node. So let's create an invoice for 10,000 sats. We can copy this invoice and close the little pop-up. And then we can right-click on Alice, hit Pay Invoice, paste the invoice, and click Pay Invoice. And here we see, so there is a little bug here as well. It says send 10 sats from Alice, but it's actually 10,000 sats. But yeah, that's no big deal. And so, yeah, basically that's what we are, that's how you design a fake Lightning network on Polar. So I'm going to stop the network. Now that we have seen this, I'm going to check if there are any questions. No questions. So back to Polar. And we'll maybe go back to, so we'll load the Plan B example, because I think that's the one that I used for this little example. So if you go to the repository, you will see that there are inside the src folder, so the source folder where the code is living, there are 2 folders, one called example, which is basically just a way to where I show you how to interact, how to write some code that can interact with your local Lightning network. And then there is a new another folder called pre-image stealing, where I gave you some instructions for today's exercise. So if we just quickly take a look at the example, which is called intercepting PTLCs. So this example will guide you through creating your first test Lightning network with Polar and how to give instructions to a node inside network. So we just saw how to design a network. And so here the goal is to see how we can give instructions to a Lightning node to only forward payments if they meet certain requirements and fail them otherwise. So we have a node and it receives a request to forward some payments as a routing node in the network. And we want to be able to instruct this node to only forward payments if they satisfy certain conditions. And we want to write some code in order to represent this set of instructions. And we want the node to be able to execute this code. And so we'll need 3 nodes, Alice, which will send or receive payments, Bob, which we'll use to route payments. And so this is the node that we will give instructions to, and Carol, which will as well send or receive payments. And so we will use LND node, all connected to the same Bitcoin node. And so that's what I did here. We can see that we have 3 nodes, Alice, Bob, and Carol, all connected to the same Bitcoin backend, but it doesn't really matter here. And now if I click a node, I can see here that I have a connect tab, which gives me various informations for me to connect some external program to the node. Of course, it's not the same connect information for all nodes. We need to connect to them independently. And so here, I'm going to share this window. I'm going to make it smaller so that we can see. I'm going to reduce the terminal as well, reduce this part of the window. Great. So basically, this is the same repository. It's just checked out locally. And we can see that we are here. Here we have, again, our example Polar exercise. So with the same README, for example. And here we are going to replace these placeholders for the configuration of our connection to our nodes with what is available in Polar. So Polar gives us the instructions. So I'm just going to reduce the Polar window as well so that we can see both windows at the same time. Here you go. Yeah, perfect. So we need basically 3 things to connect our little program to a Lightning node. We need the certificate, which is used by the program to end the Lightning node to establish a secure connection. We need the macaroon, which is used by the Lightning node to check that the program is authorized to perform actions. And we need the socket, which basically tells the program how to connect to the node. So maybe the LND socket here, it's under gRPC host here. So we just have to hit the little copy icon here. We copy the host, and we replace this placeholder. So we replace, not add it to the end. We replace the placeholder with this IP and port. So this socket information. When you see 127.0.0.1, it means local host. So basically, it tells the program that the node it connects to is on the same machine. And so you can just replace 127.0.0.1 with local host. It's the same thing. And it's, maybe easier to remember. I don't know. And then we need Bob LND certificate. So we can use it either in hexadecimal format or in base64 format. Maybe we can go with base64. So I locate the TLS certificate part. I hit copy. I replace the placeholder with this new, with the actual certificate. And I need to do the same thing with the macaroon. So what you can see here is that there are 3 types of macaroon. There is the admin macaroon, which basically has all permissions on the node. There is the invoice macaroon, which can only ask the node to create invoices. And it can also, I think, I would have to check, so maybe double check, fact check this, but I think it also is able to ask the node for the state of an invoice. So is this invoice paid or not? And there is the read-only macaroon, which, as the name implies, if you have only the read-only macaroon, you can only get information about the node. So, for example, how many channels it has, the details of the channels and stuff like that, but you cannot perform actions on the node. You cannot change how the node behaves. You cannot open a new channel and stuff like that. So for our test, what we will use is the admin macaron. This way we don't have to bother with knowing what permissions we have. So I replace the placeholder with admin macaron. And so this is just a place, this .env file is just a place where I store these connection details. And then I wrote, and so you will find it in the repository, just a few lines that take the content of this file and make it available to the rest of the program. And then we have the index.ts file, which is where I wrote the interesting part of the code. And so we are using what we call a library. So basically, it's code that is available for us to use and as an interface between our code and the LND node. So for example, Lightning here is written by Alex Bosworth from Lightning Labs. And so it's a library to interact with an LND node. And so, of course, you can find all this information in the GitHub repository. It's all there. So you can check out, for example, the library for yourself and stuff like that. And so here we use the authenticated LND gRPC method from the Lightning library in order to establish a secure connection between our program that we are writing and Bob's LND node. So for instance, here we can see that I made a mistake because I copied Alice's information instead of Bob's. So I'm just going to need to quickly fix that. So it's port 10,002 instead of 10,001. I'm just going to replace the TLS certificate with Bob's one. Oh, I need to copy the base64, not the path. And I need the admin macaron. And now we are good to go and to connect to Bob's node. So the one in the middle, which is the one we want to interact with. If I zoom out here, perfect. And so here we established a secure connection with Bob's and LND node. And then we are going to use another method from the Lightning library, which is called subscribed to forward requests. And so the name is quite self-explanatory. But basically what this method does is it lets you ask the node to tell your program every time it receives a forward request. So basically a routing request. So some payment is routed through Bob's node. And so every time it happens, Bob, the node, will send this information to our little program, which will be listening for this information. It will be printing intercepted forward request every time there is a new forward request happening. It will tell us how many millisatoshi. So one satoshi is 1,000 satoshi. So as you probably know, the millisatoshi is actually the base unit on Lightning Network. And what we are doing here in this simple example is we have a rule which is that if the amount is more than 1,000 sats, so in other words, is more than 1 million millisatoshis, we want to reject the forward request. And if the amount is equal or below to 1,000 satoshi, we are going to accept the request. And so the rest of the program is just basically launching this listening tool and listening for data from Bob's Lightning node. And so I'm going to run this program simply by running pnpm example. So you can find all details about that on the repository. I run this. And so now you see it printed listening for forward request. So that's what we can see here. And so it tells me that the program is working and is listening from Bob's node. And so now we need to see if our program is doing what we intended to do. We can, for example, go over Carol's node, create an invoice from Carol's node, for example, for 2,000 sats. So I create invoice, copy and close. Now I go over to Alice's node. I hit pay invoice. I paste the invoice. And so the amount is 2000 sats. So what we expect from the rules that we have written here in our code is that the payment should fail because Bob will reject the payment. And Bob is the only existing node between Alice and Carol. So the payment can't go through any other route than Bob. So let's see if it works. Pay invoice. So as you can see in Polar, it said unable to pay the invoice. Failure reason, no route. And indeed, the interceptor saw that we were asked to route 2 million millisats, so 2000 sats, and we rejected, so Bob Nodes rejected the payment as we asked him to do with our code because it was above 1000 sats. And so the payment failed. And now if we try, for example, to create from Carol let's do 999 sats. So I create invoice, copy and close. I go to Alice. I hit pay invoice. I paste the invoice. And this time it should work because it is below 1000 sats. Pay invoice. And as you can see, we successfully paid the invoice. We sent 999 sats from Alice to Carol. And you can see here in the logs in the terminal that Bob's node intercepted the forward request so that it was asking to forward 999 sats. And as the amount was below 1000 sats, we accepted to forward the payment. So that's just, this example is just basically to show you how you can design a local Lightning network with Polar and how you can give instructions to nodes in your network. And of course, this is one example where we have a subscriber. So we subscribe to a specific event. And so from then on, the Lightning node will send us events as they occur. So in this case, forward request. But you also have methods in the Lightning library, for example, to ask a node to open a channel, for example, or to send a payment. So you can automate a lot of things. And that's what companies or projects building on Lightning will use to interact with the Lightning nodes that they are using as their infrastructure. So they will not necessarily use TypeScript, which is the language that we are using here. They will not necessarily use this specific Lightning library, but they will tend to use this kind of tools to interact with the Lightning nodes. And to take specifically the Lightning library, it is being used in the industry, so that's why it's also an interesting tool. It's not just some tool to play and to do demo stuff. It's also a tool that can be used that is used in real projects. So it's great to know how to use it if you intend to, for example, work as a Lightning developer. Are there any questions so far? Is it clear enough? So feel free to tell me if something is not clear. And I would love to know if anyone had some time to try to take a look at the other exercise. Maybe Alphonse, did you have some time? I don't know if you're still here. Did you have some time to take a look, or was it maybe too short, or maybe you don't want to join with the replay being available? Good so far? Okay. So Alphonse or anyone else, did anyone have some time to take a look at the exercise? Because it's better if we see some propositions before we see a possible solution. Okay, I'm just reorganizing my windows. to make it more, to make it a bit easier for me to jump between things. Great. So you read the exercise, you set up Polar, but you don't have time to do it. All right. Do you still want to join me? It's okay. Did you manage to get Polar to work? Maybe you can join me and we can just discuss live the exercise and what you think we can try to do. And we're not necessarily implement something new live, but this way we can just quickly have a chat about what we would need to know in order to make the exercise. So what I'm going to do is I'm going to create an invitation link. Great. And I'm going to paste it in the live chat channel on Telegram. And so if anyone wants to join me, so for example, Alphonse or anyone else who took a look at the exercise, please feel free to do so. So in the meantime, I'm going to share again sorry about that. I'm going to share again the GitHub. So let me just put this here. Took. And here we go again. So that was basically the example exercise. Where the goal was to have some requirements on forwarding payments and to only forward payments if these requirements were met. So here, for example, the requirements were the payment should be more than 1,000 sats. And so we'll head to another exercise, which was one for today, which is on pre-image stealing. For the context, maybe it's even better to I'm going to share the slides here. So I'm going to start the slideshow. Hopefully in this display. Nope. Okay, slideshow settings. So maybe it's display 3. Start from first slide. Yeah, it's display 3. Great. So to provide you some context on pre-image stealing. So I expect most of you to know what pre-image is in Lightning, but basically, when you have a Lightning payment, you have an HTLC which is involved, and so HTLC stands for hashed time locked contract. And so, as the name implies, there are two ways that the HTLC can be resolved, either by providing the pre-image of a hash or by waiting for the HTLC to expire. So for the time lock to become to expire. And so in order to claim a HTLC in Lightning, all you need to know is the pre-image of the hash of this HTLC. And so the hash of HTLC is known by basically everyone on the route of this HTLC. And but the pre-image is initially secret, and only the recipient knows the pre-image at first. So what happens is the recipient randomly creates a pre-image, just a big number if you want. Then the recipient hashes the pre-image and he sends the pre-image as part of the invoice to the person who will be the sender of the payment. I lost my, here it is. So that's what we can see here. So the recipient Daniel randomly selects a pre-image, computes the hash of this pre-image, sends the hash to Alice inside the invoice, and then Alice creates the payment route to Daniel. And so on the route, everyone receives a HTLC that is locked to this hash, so to this pre-image. And so everyone knows the hash, but at first only Daniel knows the pre-image. And then in order to claim the HTLC from Carol, Daniel will reveal the pre-image to Carol. Carol, in order to claim the HTLC from Bob, will reveal the pre-image to Bob. And Bob, finally, in order to claim the HTLC from Alice, will reveal the pre-image to Alice. So that's basically how Lightning payments are routed through the Lightning Network. What we can see here is that any of the nodes that took part in the payment, at the end of the payment, they all know the pre-image. Okay? But it should be okay because now the payment is done. However, reminder, we saw that Daniel gave the hash to Alice inside the invoice. And so it means that if, for example, Daniel posted the invoice on social media, for example, Daniel posted the invoice on Twitter, for example, or X now, it could happen that Alice pays it because she sees on X, she sees the invoice, and then someone else sees the invoice 2 minutes later and pays it again. And there is nothing telling the second person that the invoice was already paid by Alice. And what could happen is that if when the second person tries to pay again, if the second payment goes through some of the same nodes as before, these nodes already know the pre-image, and so they can use the pre-image to claim the HTLC and so the Lightning payment for themselves without having to forward it to the final recipient of the payment. So here, for example, Carol, which was already part of the first payment, already knows the pre-image, and she knows that it is the same payment because the hash is the same, because it's the same invoice. And so she can know for sure that she already routed a payment for the same invoice. And so she knows that if she saved it somewhere, she already knows the pre-image. And so she can use it to claim the payment for herself and not forward it to Daniel. And so here the Daniel doesn't really care because he was already paid before by Alice. But Alice Prime cares because she was sending a payment to Daniel, and now the payment has been stolen by an intermediary node, which wasn't meant to receive the funds. So that's basically the issue here. So that's what I explain here in this little this little readme, this little exercise. So that's just the same thing that I'm saying again. If we want to do a demo of this, we will need a Lightning network that is. So we will need a minimal number of nodes in our Lightning network. So how many nodes do we need? We need one node, which will be the initial sender. We need one node, which will be the final recipient, so the node that sends the invoice. We need one node in the route to be part of the route in the first payment and steal the funds in the second payment. And we will need at least a fourth node in order to retry to pay the invoice later. So we need at least 4 nodes. So I did a small network here with 5 nodes. You can see here. Can I get rid of this? No. So I'm just going to make it bigger. So we can see here we have 5 LND nodes: Alice, Bob, Carol, Dave, and Erin, all connected to the same Bitcoin backend. It doesn't really matter. We can start our network. So 4 nodes would have been enough, but yeah, with 5 we can also show additional things. So the question from Alphonse: sometimes when using a Lightning wallet, the wallet says the invoice is already paid. Does not that fix the issue? So that's a great thing that we can demonstrate. So for example, before we start doing anything, so we won't start our little tool. We won't connect our code to this yet. If I select Erin and I create an invoice, so for example, let's create an invoice for 1,000 sats. I create the invoice, copy and close, and now I go to Alice and I ask Alice to pay the invoice. So I ask Alice node to pay the invoice. It works. Now if I ask Bob to pay the invoice, what you will see is that Bob's node doesn't know that the invoice was already paid. So it will just say, actually it didn't work. I don't know why. Do I have something running already? Yeah, I need to stop this. Okay, let's try again. Maybe let's quick mine. Shouldn't matter, but let me create another invoice, 1,000 sats or 10,000 sats. Let's go for 10,000 so that we can feel a bit richer. Let me go to Alice, pay invoice. So the invoice is paid. And if I go to Bob and try to pay the same invoice, oh, that's great. Why isn't it working? If I try with Carol, it should work. Yeah, I'm having a nice demo effect. It should be working. Why isn't it working? You know what? Let me stop the network. Yep, it stopped. I don't have anything running, right? Nope. Start again. Create invoice. 10,000 sats. Copy and close. So Alice should be able to pay the invoice. Oh, maybe, but it worked in my test. That's what one. Let me try something. Create invoice, 10,000 sats. And let's try first from Carol. Okay, and now from Alice. Okay, I don't know why it doesn't work. It should be working. But basically, to answer your question, when multiple Lightning nodes see the same invoice, they have no way of knowing that the invoice was already paid by someone else. And they are not going to, for example, send a message off-band to the receiving node to check if the invoice was already paid or not. And so if your Lightning wallet says that the invoice is already paid, usually what this means is that it got a response So actually, okay, I figured it out. That's what is happening here. You're right. What is happening here, okay, is that every node in the route is behaving honestly. So what is happening here is that every node is routing the payment as expected. So you're entirely right. What we are seeing right now is what you describe, is what we see in the real world if every node is honest. Basically, what happens is that the payment works the first time, and then the second time, every node routes the payment until up to Erin, and Erin just says the payment was already, the invoice was already paid, no need to pay again. And so and the error goes back the other way around up to the sender. So that's why here, every time we do a second payment, it fails. But so that's because everyone is honest. But for example, Erin could say, you know what? If someone pays me twice, I will keep the two payments. And so Erin could say, could accept the second payment. Or as we are going to see, some nodes in the route could start behave not honestly. And there is nothing in the protocol that help protect you against this kind of stuff. So let me just try to see that it works and there isn't any other problem. So I'm going to push the solution after the live session. So here we didn't take a look at the code for this exercise yet, but we see that it's listening. And so we are connected to Dave's node here. So let's go and let's create another invoice from Erin. Let's take 11,000 sats. Great. Create invoice, copy and close. I'm going to go, so let me just, split my view here between the two windows. Great. So here it's a bit small, but it's working. Let's go to Alice and ask Alice to pay the invoice. So it should work. And here we see that Dave's node. So we will see the script, the code later. But we asked Dave's node to save the pre-image. And so here we can see that we saw the pre-image and we saved it for later. And now if Bob tries to pay again, so I'm pasting the exact same invoice, pay invoice. And so we see that we know the pre-image already because we saved it. And so Dave stole the amount, and you can see that the payment worked this time. If I try again with Carol to pay the same invoice, pay invoice, the payment worked again. And so it's just that when we are not using any, when we are not telling our nodes to behave in a malicious manner, when everyone is honest, if I do it again, so I shut the terminal, this program down, and we try again to create an invoice and pay it twice, just to remember what happened. So for example, Alice pays the invoice, it works, great. But now if Bob tries to pay the same invoice, it fails. And that's because every node in the route is honest and prevents, and so basically it's Erin that prevents Bob from paying twice. But now with our little code, which is really not big, sorry, that's what I wanted to do. If I run again the script, it's really like 10 lines of code. And this time, if Erin, so create an invoice again, 20,000 sats or even more. Let's do 100,000 sats. Create invoice. Alice pays the invoice. So the first time it goes through and Erin receives the funds. But now Dave's node has learned the pre-image. It has saved the pre-image. And if someone does another payment with the same hash, it will know that it can reuse the pre-image. So for example, let's take Bob and try to pay the same invoice. And so you can see here that apparently the payment succeeded, but it's actually Dave who took the funds. So the 100 and 1000 sats plus this here is the fee that Dave was supposed to collect for routing the payment to Erin, but since he didn't route the payment to Erin, Dave was also able to keep the fee, and Erin got 0. So you're right that in your everyday practical experience, you can see that the wallet says that the invoice is already paid, but your wallet could also show that the invoice. Your wallet could just tell you that the payment was sent and that it was received by your recipient. But actually, the payment wasn't really received by the recipient because someone else did the payment prior to that, and some node in the route learned the pre-image and used it to claim the payment for themselves. And your Lightning wallet wouldn't be able to tell if that was the case. So that doesn't really fix the issue, as you can see. I hope it was clear. We can take a look at the code that does this. As you will be able to see, it's not really a very big program. And so here we connect to Dave's node and to Erin nodes. The connection to Erin node is only to be able to check that she doesn't receive funds when Dave is supposed to steal them in our example. But we don't instruct Erin's node to do anything. As you can see, we have two little subscribers to Dave's node. We have one subscriber that listens to forwards events, and another subscriber, which I call the interceptor, that subscribes to forward request. That's just we need two methods here because we can see if we take a look at the Lightning library. So to do so, you can just usually in a lot of development text editor, if you hit command or control and click, you can see some more details about the method that you are using. Or else we can just go to the Lightning. So if I go to this example here, we can go to the documentation for the Lightning library that we are using here. And we can just see all the methods and see which one we need to use in order to do what we want to do. But because what we want to do is to be able to, when we see a forward a payment go through our node, our attacker node, what we want is when the payment is settled, we want to be able to learn the pre-image for this payment. So that's the first one. And the second one is we want to be able to control when the payment goes through our node, we want to be able to settle it for ourselves and not accept and not forward it to the next node. So that's two things that we need to be able to do. And so a logical first step would be to check out the forward request method, the subscribe to forward request method, to see, because that's the one we used already in our little example where we had already set up an interceptor in order to only forward payments that were less than 1000 sats. So we can reasonably guess that it will be useful to claim the payment for ourselves. But we need to check that it also lets us read the pre-image for the payment. And so if we take a closer look at the subscribe to forward request in the documentation, we can see that the name of the event is forward request. We will see so that this here, the fact that the event is called forward request tells us that in our subscriber here, the Dave interceptor will listen to events called forward request. That's why it's called forward request here. But yeah, what we see here is what we get, what the node that we are listening to gives us every time there is a payment that occurs. So there is 3 functions: accept, reject, and settle. In the first example, the one where we wanted to forward payments that were less than 1,000 sats and to block payments that were more than 1,000 sats, we used the accept and the reject methods. So basically, we called the accept function when the payment was less than 1,000 sats, and we called the reject function when the payment was more than 1,000 sats. We see that we have a third function, which is called settle, which is a short circuit function, and which takes as a parameter the secret, the pre-image of the payment. So that's what we are going to use to claim the payment for ourselves. But what we can see as well is that in the rest of the fields that we get every time there is a forward request, we get the fee, we get the hash of the payment. Could be useful, but what we want is a pre-image. We get the in channel, in payment, so basically where the payment comes from, messages, the number of tokens, the onion, so that's some technical stuff, the out channel where we need to send the payment downstream, the timeout, and the number of satoshis. But what we can see is that in this method, we don't see the pre-image. So we will probably need to use another method to learn the pre-image. And this other method, we just have to go over the documentation. And if we go to the next function, which is subscribe to forwards, this one subscribe to HTLC event. So it's quite close to the previous one, but the difference is that this one, the subscribe to forward request, it has off-chain read and off-chain write permissions. That's why we need the admin macaroon for this one. And the off-chain write comes from the fact that it can perform actions on the HTLC. We can tell the node to accept or reject or settle the HTLC in place. And so that's why we need a write permission, and that's why we needed the admin macaroon. Whereas the subscribe to forwards method, so not subscribe to forward requests, but subscribe to forwards, only requires a read permission. So we could have make this specific method here, subscribe to forward, works with only the read macaroon. We don't need the admin. We need the admin for the other function, because this function here doesn't perform any action on the HTLC. It only gives us some data about the HTLC that is being forwarded through us. And so yeah, as something I forgot to tell you, we will receive a forward event twice for every payment. Yeah, usually twice. Once when the payment starts, and everyone starts, and every node creates HTLCs, we receive the forward event. And then we will receive a second forward event when the payment is failed or is succeeds. And in this second forward event, we can see the secret here, the pre-image. So we only see this if the payment succeeds, of course. But so we can see on the way back, we can see the pre-image. So that's great. It's everything we need. We have one function that we can use. So it's the function called subscribe to forward request. We can use its function to settle the payment for ourselves if we already know the pre-image. And we have the subscribe to forwards function that we can use to learn the pre-image the first time we see a payment. So that's great. And so that's what we are going to use here. So we are using Dave node here because it's the one closer to Erin. So that means that we can try to pay. We can pay the first time with Alice, and then we can see that if we retry with Bob and Carol, Dave will be able to claim the payment both times. And we can do this in whatever order we want. So that's why I choose to use Dave's node as being the attacker. But we could have used Carol, for example, and it could be an interesting exercise as well, because we would see that if we use Carol as the attacker, then Carol would be able to steal, for example, if Alice makes the first payment, Carol would be able to steal from Bob if Bob does the second payment. But Carol wouldn't be able to steal from Dave because she isn't on the route from Dave to Erin. So that could be something interesting to demonstrate. But for now, we are using Dave as our attacker. And so we have Dave sub uses the subscribe to forwards method. So basically, it will be listening to forward events, and it will be saving the pre-image for later. So that's what this little bit of code does. So anytime there is a forward happening, so both on the way from the sender to the recipient and on the way back when the payment is settled, we'll get a forward event, and we can get the data from this event. And especially if there is a secret in the forward message in the data we get from Dave node, we can save it for later. And so here we have a variable called pre-image, which is initially just an empty string. And the first time we see the pre-image, we replace the existing string with the new pre-image, and we log the pre-image. So that's what we saw here. So here we see what happened is we detected a new payment attempt. The payment settled. We saved the pre-image and we printed it in order to be able to follow everything that happens. And then there is a second part, which is what we call the interceptor, which uses the subscribe to forward request method. And this one, so it prints the hash of the payment, because as a reminder, we don't have the pre-image in the subscribe to forward request method. We don't have access to the pre-image, but we have access to the hash. And we use the hash to check if we already know the pre-image for this payment. So basically what we do is we hash the pre-image, and we see if the hash of the pre-image, so that's what we're doing here, is equal to the hash of the forward request that we just received. And if that's the case, it means that we can settle this forward request right now and claim the funds for ourselves using the pre-image. So that's what is happening here. And in order to be sure that it worked, we also use the get channel balance method from Lightning, which just gives you the total balance that the node has on Lightning inside Lightning channels. And we do the same for Erin, which is the intended recipient. And then we wait. We use the settle method from the forward request, the settle function from the forward request method. So you can see here we have this settle function that we are using here, and we pass the pre-image that we learned from the previous payment inside, as a parameter to the settle function, and this lets us claim the funds for ourselves. And then what set timeout does is it just waits for the number of milliseconds that we write here. So why do we need to wait? We need to wait. So here we wait 1 second. Maybe it's a bit much, but it's just to be sure it works. We need to wait because once Dave node use a message.settle here, that is to so use the settle function in order to claim the funds for himself. we still need to wait for this settlement to be broadcasted back to, for example, Bob's node, if Bob was the sender of the second payment. So that's why we need to wait before checking Dave balance and Erin balance after the payment. And here, what we print is just the difference between Dave's balance after stealing the payment and Dave's balance before, and the same thing for Erin. And so that's what we see here. We see that after we steal, the difference is in fact 100,001 because we stole our own fee as well, sats, and that Erin got 0. So that's basically how this preimage stealer works. And as you can see, it's very short. It's not especially difficult. And so a lot of nodes could be doing this. And the only reason why we are not seeing this right now, so there are two reasons. One is, how could we really know if a node was doing this? And two, currently, Lightning isn't really being attacked a lot. And people are behaving quite honestly. So yeah, I hope it's clear. Let me know if it isn't, if you need another demonstration, maybe. Maybe what we can do is to demonstrate the fact that this needs Dave to be on the route, for example, the second time in order to be able to steal the payment. We can, for example, create another LND node. Do I need to stop the network before stealing? No, here you go. We can create a new node called Frank, and we can connect Frank to Erin directly. Let's open a channel. Here you go. We are going to check that our little program is still on. It is still on. Great. So I'm going to increase this so that we can all follow. And so I'm going to, like before, create an invoice from Erin. Let's do 10,000 sats. Alice will be the first one to pay this. So Alice sees the invoice in social media. She likes Erin, and so she pays the invoice for Erin. So we can see that our little program worked as before. We were on the route of this payment. We detected, we saved the pre-image for later. And now if Bob tries to pay as well, not knowing that Alice already paid, Dave will be on the route again. And so Dave will be able to steal the payment. Awesome. But now if it is Frank who also sees the pre-image, the invoice on social media, and also likes Erin and wants to pay as well, but doesn't know that Alice already paid and Bob already paid, Frank can try to pay as well. And so what do we expect to happen here? What we expect to happen is we expect the payment to fail, because this time Dave won't be intercepting the payment, and it will go to Erin, and Erin will say, I already received the payment for this invoice, and will hence fail this payment. And that's what we can see here. So it only works if a malicious node is on the route of a second payment. But this can happen quite a lot, especially for big nodes. Awesome. Great. I'm going to stop. No, actually. So that's what we covered this here. Oh, shit. All right. I'm going to start from the current slide again. I hope it was all clear. Another thing that is worth noting here is that, of course, there is the ability for a routing node that already knows the preimage to steal the payment, and it wouldn't be detected. So the only way to detect it would be if, for example, the second sender sends a message to the recipient asking if they received the payment, and the recipient says no. And then we can know that someone in the route must have stolen it. But that's it. There isn't really a way in the Lightning protocol to detect this kind of theft. And another thing that an attacker could do is called a wormhole attack. Sometimes I call it a sandwich attack as well. And basically, it allows an attacker to steal payment fees from other routing nodes. And so this attack doesn't need the payment to be tried again. It will work on the first payment. So there is here it isn't due to reusing invoices. The attack can be carried out by an attacker that controls at least two nodes in a route. So, for example, here our attacker controls B and D, so Bob and Daniel, and so we have every node in the route creating PTLCs like always. Sorry, yeah, about that. The last two nodes, the last one should be E, like Erin, and not T again. But basically, the recipient gives the preimage to Daniel in order to claim the funds. And since the attacker controls both Daniel and Bob, he can just send the preimage that he received with the Daniel node directly to the Bob node. And so this completely bypasses the node in the middle here. And then we can use the preimage with Bob to just claim the PTLC from Alice. And from Alice's point of view, the payment settled as usual. But what happened is that Bob was able to. So here the amount in this PTLC is basically the amount that Alice wants to send to Daniel, plus the fees for Bob, for Carol, and for Daniel. And here the amount of this PTLC between C and D is the amount that Alice wants to send to Erin, plus the fees for Daniel only. And so by squeezing Carol's node in the middle, the attacker is able to steal the fees that Carol should have received. And so Carol gets nothing, and the attacker keeps their own fees. But yeah, this is business as usual. They would have had their own fees if they were honest as well. But they also keep Carol's fees for themselves. And once again, there isn't really a way to prevent this kind of attack. This attack can be maybe detected by Carol's node, because this node will detect that the payment failed, but it won't necessarily be aware that it failed because it was squeezed out of the route. Maybe it could have failed for other reasons. So yeah, that's another thing that can be done with this preimage piracy kind of attacks. And funnily enough, there is a tool that exists, which is called, where did I put it? Oh, I didn't save it. Okay. It's called Preimage Stealer. So yeah, great name. You can see it's here. And so it's a utility to automatically claim Lightning Network PTLCs with rebuilt preimage. So it's basically doing exactly what we just did with our polar exercise. And you can run it and connect it to an LND node. So maybe it would be fun to try to make it work on a polar network, because here you can see that we need just basically the same information. So the macaroon, the certificate, the port, and the host. So the port and the host is the socket, what we call the socket in our example. So we just need quite exactly the same connection information as in our polar exercise. So I didn't try it, and invite you to try it for the next session. But we could run this, so it uses Docker as well, by connecting it to a node in our polar network, and test if it works. This node has a watch-only mode, so you can either run this as a real attacker and still sats. So anytime someone tries to reuse an invoice and send funds in a route where you already know the pre-image, you can steal the funds, or you can run it in a watch-only mode, where you don't actually steal the funds, but you count how many funds you could have stolen. So yeah, there are two. You have to decide if you want to be evil or not. So I think it hasn't been maintained since 3 years. So maybe it could be fun to refresh it. I don't know if it's broken since with any update to, for example, to the LND RPC. So we'd have to check this. But yeah, and what would have been? I'm not aware of any big Lightning node that run it in watch-only mode. But I think it would have been a great way to attract some attention on the fact that you shouldn't be reusing invoices, and you shouldn't be posting invoices online. And so it leads me to the next slide, which is solutions. The number one solution to this is to not reuse invoices, and so to also not post them publicly. Because if you post an invoice on social media, for example, there isn't a way for someone to know if the invoice was already paid or not. The only way would be if someone paid the invoice, it would be for them to post a message telling everyone that they already paid the invoice. And for example, to prove this, they could post the pre-image alongside their message. And that's actually, if you have used Zaps on Noster, for example, that's actually one of the things that Zaps do, is that you have a receipt when it's paid, which can be useful for this kind of stuff. And so another thing that really helped in this regard is that we now have static identifiers for Lightning payments. So for example, LN URL. Sorry, so this includes Lightning addresses. We have Bolt 12. And this means that now people can just post one of their static identifiers publicly online. And then someone who wants to pay them will get a new invoice each time. And so this helps avoiding to reuse invoice. And I think that we just really don't see a lot of invoices being broadcasted publicly on social media now, or at least we see less of them than we did in maybe 2020 or 2021, before, for example, Lightning addresses became really prevalent in the Bitcoin and Lightning ecosystem. And another thing that helps address this problem are point time load contract. So it looks like HTLC, but it's PTLC. And the difference is that instead of reusing the same pre-image across the whole route, each routing node will have its own point on the elliptic curve. And so basically that's like HTLCs, but instead of using the same hash and so the same secret on the whole route, everyone gets a different secret. So for a long time, what prevented this from being, for example, one of the major things that prevented PTLCs from being implemented in Lightning from the get-go was the fact that for it to be efficient, we needed Schnorr signatures, which weren't in Bitcoin when Lightning started. Now they are since it approved soft fork. So I think PTLCs should be much easier to implement now. They are still not here today. And I don't think I have seen recent discussions around implementing them. But yeah, PTLCs are great, and they would prevent stealing from reusing invoices. They also prevent wormhole attacks because since every node gets its own secret, it isn't possible to do a wormhole attack where you reuse the secret between two or more nodes that you control. And it improves privacy because another thing worth considering here is that the attacker that controls B and D is also able to know that the payment at some point came from A and went to E. So once again, here it is E and not D. So it knows that there is one node between them because it knows that it was asked to forward the payment to Carol, and it knows that on this second node it received the payment from Carol. So basically, it knows that this part of the route there is only Carol, and so it cannot be sure 100% that the sender was Alice and that the recipient was Erin, but it can then use some heuristics on the length of the route to say that there is a high probability that the payment in fact came from Alice originally and went to Erin in the end, because it's unlikely that there is a working route that has more than let's say 3 routing nodes. So using this kind of heuristics, because HTLCs reuse the same hash for the whole route, you can de-anonymize payments and so completely remove some of the benefits of onion routing in Lightning. PTLCs would be great for that as well. And so here you have a little PTLC article on PTLCs, a bit technical, that I wrote some time ago. If you want to give it a read, and maybe we could, it could be a subject for a future session as well. Let me check what time it is to see if. Okay, yeah. So, are there any questions regarding what we saw just here? I hope it was clear. I saw that Alphonse, I saw you followed well, so that's great. Was it interesting? Yeah, we'll have time maybe later on the Telegram to have some feedback about this kind of exercises. Maybe quickly we can get over the recent news around wallets. And it's a bit more an open debate because we saw a few news regarding wallets in the last 2 weeks. We saw that Exodus, which is a multi-coin wallet, but which supported Bitcoin and Lightning Network as well, they announced that they are ending Lightning support. And for reference, what they were using was Wallet of Satoshi for Lightning. And so, of course, when Wallet of Satoshi ended support in the United States, they had no choice but to stop support for Lightning in the US as well. But now they have announced that they also stopped Lightning support everywhere, basically. So they will remove Lightning from the wallet. So if you're using Exodus for Lightning, please withdraw your sats. So anyway, they were actually just using Wallet of Satoshi's API and Lightning infrastructure. But yeah, that's worth noting. We also saw that Zeus wallet implemented support for Cashew, so basically ecash. And there was a release by Breeze of a reference wallet implementation that uses their nodeless SDK. So let's just cover this quickly. Here you can see here. So it's called Misty Breeze. And basically what a reference implementation is so we discussed already in previous sessions, we discussed the two Breeze SDKs. So there is the native SDK, which is a Lightning node running in the cloud with the keys remaining on the user device. And there is the nodeless SDK, which uses Liquid to store the funds, and then uses swaps between Liquid and Lightning to receive and send on Lightning. So of course, it helps for very small amounts. For example, when you receive for the first time and you don't want, it doesn't make sense to create a Lightning channel and stuff like that. And so what this reference implementation is basically Breeze creating an app to show other developers how to integrate the SDK and to show some to set some standard around UI, UX, and stuff like that. So to show other developers how they could implement things. So yeah, that's great. And so here it is. Here is the announcement from Exodus, by the way. And so support ends on May the 13th, 2025. So you need to withdraw your funds before that deadline. But it made me think, because what we saw basically is a lot of recent announcements for Lightning wallets really focused on helping users onboard to Lightning with what we can call custodial solutions. And so, yeah, Alphonse, as you say, so I quote your comment. We read many people saying Misty is not self-custody. Any word about it? Basically, that's why I included it in today's session. Indeed, a lot of the news that we see regarding new Lightning wallets is integration of either ecash or liquid swaps. And in both cases, although it's a bit different, liquid and ecash are custodial solutions. So for ecash, really, I think there is no one arguing really that ecash is not completely custodial. Basically, it's just you have to trust the mint to not run away with funds. I know there are some mitigations in order to make it harder for the mint to steal the funds from its users. So, for example, there is in Fedimint, which is federated ecash, the fact that there is a federation helps, because it would require a majority of what they call guardians, so a majority of members of the federation to collude in order to steal funds. So that's one. In Cashew, for example, the idea is quite different, because Cashew is meant to be to make it really easy to spin up a new mint, and so they don't have this federation ID. But what they have, for example, is a tool that Calais developed, which constantly tries to withdraw funds from mints in order to check that they are honoring withdrawals. And since in Cashew, there is a great privacy for the users of a mint, the mint cannot just know that the withdrawal comes from this auditing tool, and so honor the withdrawal for the auditing tool and not for other users. It can't tell which user is trying to withdraw. So if the withdrawing tool, if the auditing tool is able to withdraw, presumably it means the mint still has funds. Maybe I can try to find it. Cashew audit. Yeah, okay, I have some tweets here. Great. So it's called audit.8333.space. So it's what is called round robin Cashew. So basically, it's a Lightning auditor. So the idea is that this tool will automatically, every I don't know what the period is, but every few seconds, every minute, try to withdraw funds with Lightning from a lot of the mints. So here are all the mints that are periodically audited by the auditor. And so, as you can see, for example, the mint.nostrich.cc failed to the last withdrawal, let's say. So as you can see, for mints, there are still mints that has some errors, but are working afterwards. So it doesn't necessarily mean that there is a problem with a mint and that it is actually being rigging users right now. Sometimes the Lightning payment can fail for other reasons, but it's a great tool to assess the health of a mint. Another idea of Cashew is to try to diversify your risk across different mints, different good mints, hopefully. But yeah, still it's custodial, and so there are little tools that help by auditing mints perpetually, but it remains really custodial. And for liquid, it's a different problem, but still it's a federation, so there are arguably a few dozens of members in this federation, but still it remains a federation. And if you want to, and you cannot be sure that you will be able to get your funds back on the Bitcoin main chain once you have put them in liquid. So what you can do, and what a lot of people actually do when they want to get liquid Bitcoin to Bitcoin, either on-chain or Lightning, is that they will swap. So they will do a swap with someone who wants to do the other trade and who wants to send real Bitcoin into liquid. But if suddenly the Liquid Federation stops, and so the other way you can depeg liquid Bitcoin and get it back as real Bitcoin is you can ask the mint, so you can ask the federation to do a depeg and to give you back a real Bitcoin on chain in exchange for liquid Bitcoin. But basically, you trust the federation that they will allow you to do so, and so that's in that sense that it's that liquid is custodial as well. And there are good chances that if for some reason the Liquid Federation was to stop at some point doing depeg, so not depeg, sorry, peg out, then the trust in the liquid Bitcoin token would evaporate quite quickly, and you wouldn't be able to do swaps in order to exchange your liquid Bitcoin against real Bitcoin. So that's why it's really a custodial solution as well. Now the discussion is around if there are many custodians in the federation, and it takes a lot of them to collude in order to steal funds from users. How much of a problem is it? I still think that it really depends on a lot of factors. For example, in which jurisdictions are these custodians based? But I think it's something we could see someday, and so that's why I think that the critics arguing that Mr. Breeze is not self-custody are quite grounded. So it's a custodial Lightning wallet. Maybe it's the custodial Lightning wallet where the decentralizations of the custodians is the best currently, but it's still a custodial Lightning wallet. And so that's, yeah, I think there is a signal here, a weak signal in the fact that we are seeing lately a lot of news around the fact that around new. So we're not seeing only this, of course. I'm not saying that it is the only thing that we are seeing, but we are seeing a lot of things about Lightning wallets implementing custodial solutions. Often it is seen as an onboarding solution, and I've made the case for it myself. I think in one of the first session of this of the lab. So basically, the idea being that for when you receive for the first time on Lightning and it's small amounts, it doesn't make sense to create a new Lightning channel. For example, if you receive 1,000 sats, the cost of opening a channel will be far bigger than that. And even if it's not bigger, for example, if we are at 1 sat per vbyte, like we are right now, the cost of opening the channel will be like maybe, I don't know, 500 sats. So still, you could do it. But now the question is, if it is an LSP that opens the channel to you, how much sats are they supposed to put in the channel? Because they're not going to create a 1,000 sats channel. It doesn't make sense. It could end up being completely unspendable if the fees were to increase suddenly. So you need to have at least some economic value in a wallet for it to make sense to open a real Lightning channel. So that's why I think it makes kind of sense to have some kind of intermediary solutions in order to onboard users. But there is really it's a bit of a slippery slope, if you want, and there is really a need to we are not sure. I think we are not sure yet that with a user that was onboarded using a custodial solution will upgrade to the self-custodial experience once they reach a certain amount. And so, we still have to assess whether it is the case or not. I'd like it to be the case. And now there are also solutions like Arc, which are not perfect either, but at least you have. I think we can say that Arc is self-custodial, and so it is an interesting solution because it doesn't have this initial inbound liquidity problem. But it's great. So we still have to see how it evolves. I think I'm definitely more fond of solutions that really integrate both custodial and self-custodial Lightning and really see custodial as being a first step. Whereas there are other solutions where really the wallet only works in a custodial manner. For example, if we regard liquid Bitcoin as being custodial, then Misty Breeze, as of today, seems to be more of a custodial wallet because it only supports the nodeless SDK, and so having your funds stored on liquid and then used and then using atomic swaps to either spend from liquid to Lightning or to receive from Lightning to liquid. And so there is a real difference, I think, between wallets that aim to, in the end, turn their users into self-custodial users. And so maybe you start with a custodial solution like ecash, and then once the user has enough funds you automatically open a channel for them with an LSP, for example. And so that's there are a few wallets doing this, and so it's really different from wallets that are fully custodial and with no real easy path for the user to seamlessly go from custodial to self-custodial. So yeah, but that's it for today. I hope it was interesting for everyone. Thank you for all of you who stayed up until now. It's been not 2 hours because we started a bit late, but it's been almost 2 hours. So thanks a lot. If the polar exercises were interesting, I'll try to quickly propose you a different set of exercises, at least one other exercise for next week. Not next week, for the next session in 2 weeks. It would be great, if we try to have some of you try to take a try at the exercise before the live session. Maybe we can arrange another quick internal session, so not with no replay, not on YouTube, no stuff like that, next week, so between the 2 live sessions, in order to prepare the exercise, to see if there are blocking points, stuff like that, to help you set up Polar and stuff like that. Because what I'm using right now is a machine that I'm using for my daily job as a developer. So of course, it might be not as easy for you to set up Polar and Docker and stuff like that, depending on what machine you are using. So we can definitely do a session just without any replay on YouTube, to just make sure that everyone is able to set Polar, to set up Polar, and to start using it to set up TypeScript and something to write a little bit of code and stuff like that. So yeah, thanks a lot. Thanks, Alphonse. Thanks, Geoffroy. Thanks a lot, everyone. And see you soon. Let me just quickly share again the Telegram if someone is not there yet. This way they can join us. Let me check quickly. Up the Telegram group. Here you go. So if you scan this, you'll find our Telegram group, and we'll be able to chat there in between live sessions. So yes, see you there. And see you soon. Thanks a lot. Bye-bye.